When I was a kid on swim team, once a year we would have a party where we would launch water balloons at each other from across the pool. So, say we've got pool deck, the water, so there's going to be some kids on this side of the pool. And they have a catapult launcher. Then there's going to be some kids on this side of the pool. Now the pool is 25 meters across. And we launch the water balloons, and the goal is to launch those water balloons with an initial speed and angle such that it goes across the pool and hits your friends on the other side. So let's say that the initial equals 25 meters per second. Theta equals 20 degrees. We know that D equals 25 meters. See if the water balloon makes it across the pool. So to find out if the balloon crosses the pool, we basically need to find x. So we know we need to use this equation, but we need to find time, and we know that the y height when it lands should just be 0. So we've got everything we need to find time from this equation. So start here, find time, plug in, find x. So we don't need these equations anymore. We can get rid of those. So finding time from this one, we know that final and initial y heights are 0. So then 1/2 gt squared equals v initial sine theta times t. But now there's a t on each side we can cancel. So get rid of this t, get rid of the squared. Then we know t equals 2 v initial sine theta over g. So that should be 2 times 25 sine of 20 degrees over 9.81. T equals 1.74 seconds. And then we need to plug it into the x equation. So x equals v initial cosine theta times t plus x initial. Well, we know x initial is 0. And so we can put numbers in. X equals 25 cosine of 20 degrees times 1.74. x equals 40.95 meters. So 40.95 is greater than 25, x is greater than d. Answer is yes. Balloon crosses the pool. So now if we want to find this maximum height, h, the peak, because it's the launch height and the ending height are the same, if we want to find the peak, we can use the peak equation. So the peak equation that we got was h equals v initial squared sine squared theta over 2g. So if we plug numbers into here, then we get 25 squared sine squared of 20 degrees over 2 times 9.81. That equals 3.73 meters. Max height that it reaches on its flight. And because this max height equation is for something starting and ending at the same height, that also means that this parabolic path is symmetric. So the max height occurs exactly in the middle of the path.